If you observe the sun's path in the sky on any day, you would see something like this. It rises in the east, moves across the sky and sets in the west. Many people believe that sun rises exactly in the east and sets exactly in the west. But that is not true. The location of the sunrise and its path across the sky changes with seasons throughout the year. Take a look at this beautiful composite picture made by an astrophotographer. It shows the position of the sunrise in different months of the year, taken from the same location in the northern hemisphere. If you notice, in the months of winter, that is during the months of December, January and February, sun rises more towards the south of east. As months progress, it moves slowly towards the north of east. In the months of summer, that is during the months of April, May and June, sun rises more towards the north of east, reaching its farthest north in June. After that, the sun starts moving south again, reaching its maximum south of east in December. Then again, it moves back northwards. And the cycle continues. So the sun keeps moving between north and south of east. There are only 2 days of the year where sun rises in the exact east and sets in the exact west, which are in the months of March and September. Here is another composite image that shows the sun's location and its path across the sky on different days of the year in the northern hemisphere. Sun reaches its maximum north of east on June 21st in summer. Let's take a look at a graphical illustration of how sun's path across the sky would look like on this day. On this day at noon, sun is directly above the head, reaching its highest point in the sky. This is called summer solstice. As days progress, sun moves towards east, and in the fall around September 22nd, sun rises exactly due east. On this day, sun's path in the sky looks like this. This is called autumnal equinox. Then, sun continues moving south of east, and in the winter by December 21st, it reaches its lowest point in the sky. On this day, the sun's path in the sky looks like this. This is called winter solstice. After that, the sun moves back northwards again, and by March 21st, sun rises exactly due east and sets exactly due west. This is called spring equinox. And by June 21st in summer, sun reaches its farthest north again. And the cycle continues. Also, if you notice that in the summer, sun's path in the sky is longer. That is why we have longer days in the summer. And on equinox days, where sun rises due east and sets due west, we have equal day and night. And in winter, sun's path in the sky is shorter. That is why we have shorter days and longer nights in the winter. So that is how the rising position of the sun and its path across the sky changes with seasons. For most of us, this may look like some special knowledge of astronomy. But ancient people clearly knew all about this. Astronomy was part of their daily life. Ancient Indian astronomical wisdom still reflects in many temples across the country. Take a look at this beautiful temple, for instance. This is Padmanabha Swami temple located in the state of Kerala in the southern India. It's a place where art meets astronomy. This temple was built based on precise astronomical rules. The precise orientation of the main tower becomes evident through a rare visual spectacle that unfolds twice every year. Many people gather to view this astronomical event. Let's look at the beautiful astronomy embedded in this temple. Earlier we have learned that only on 2 days of the year, on equinoxes, sun rises due east and sets due west. Amazingly, the main tower of this temple was built facing the exact east. On the days of equinox, on March 21st and September 22nd, give or take a day, one gets to see the setting sun passing exactly through all the window openings in the tower in succession in roughly 5-minute intervals. The tower is built precisely facing east. On days past the equinox, the setting sun gets blocked by the tower structure because the rising and setting positions of the sun either move northwards or southwards. This ancient Indian temple is an architectural marvel that showcases ancient Indian astronomy, science, and engineering. We have just seen how amazing astronomers our ancestors were. Many of us do not even have a fraction of this astronomical knowledge what our ancestors had. But why thousands of years ago people needed such advanced astronomy? It is because astronomy was closely linked to their survival. Why? Well, if you see, for much of the human history, our ancestors were hunter-gatherers. They hunted, killed, and ate large animals, collected nuts, berries, and other seasonal foods for survival. In extreme winters, they sheltered in caves to keep themselves warm and safe. So knowing about the migration of wild animals and seasonally available foods and planning for winter shelters, simply saying keeping track of seasonal cycles was extremely important for them. And how ancient people kept track of seasons? Amazingly, our ancestors watched and learned from the sky. They related the seasonal cycles on the earth to the cycles in the sky. They observed the northward and southward motion of the sun in the sky and how it changed with seasons. Using this, they were able to predict the upcoming seasons. Then around 11,000 years ago, the Ice Age ended. Many animals, such as woolly mammoth, went extinct. Large animals became extremely rare. And this was the time our ancestors invented agriculture and started producing plant-based food. But again, agriculture strictly depended on seasonal cycles on earth. They had to know exactly when to plant the seeds, when to grow, and when to harvest the crops. So predicting upcoming seasons and keeping track of time became more important than ever. They strictly needed to track the days and seasons to keep the agricultural cycle in sync with the seasonal cycle on earth. So they created a tracker using various patterns in the sky, such as the changing position of the sun with seasons, the repetition of moon's phases approximately every 30 days, and the appearance of certain stars or constellations in particular seasons. So naturally, they related what happened on earth to what appeared in the sky. Sky was their only accurate way to keep track of time. So let's look at a basic tracker they have created to track days and seasons. Ancient people noticed that our moon goes through phases. Here are the different moon phases anyone could observe from the earth. And these phases repeat approximately every 30 days. To say simply, from one full moon to the next full moon, it takes around 30 days, the moon cycle. And we have already seen how ancient cultures observed the sun's position in the sky changed with seasons. Ancient Indians realized that from one summer solstice to the next summer solstice, that is for the completion of a full cycle of seasons, it took around 360 days, the sun cycle. So we have the sun cycle, where it takes 360 days from one summer solstice to the next summer solstice, or for a full cycle of seasons, and the moon cycle of 30 days. Interestingly, early cultures observed that for one sun cycle, that is from one summer solstice to the next summer solstice, 12 moon cycles occurred. In other words, adding 12 moon cycles, that is 12 multiplies by 30 equals to 360 days. So by simply using the phases of the moon and the sun's position in the sky that changed with seasons, they have created a tracker to track the days and months to predict the upcoming seasons. And this became our calendar that we use today. That's how our calendar was created. Many ancient cultures built a calendar using the cycles of the sun, the moon, and the stars. Eventually, more accurate calendars were created using astronomy. Ever wondered why there are 12 months and 365 days in a year? They are astronomical cycles. Calendar is a topic where ancient astronomy meets modern life. Astronomy lives with us in our daily life. Our ancestors were amazing astronomers. Astronomy is in our DNA. Astronomy is the oldest science of humanity. And if you are thinking why it is that the location of the sunrise changes with seasons, we will learn more about that in this course. Until then, keep looking up.